Okay, I'm going to start by drawing an equilateral triangle. As you know, all the angles inside the equilateral triangle are 60 degrees. I'm going to draw the perpendicular bisector of that line. So that makes that angle 30, and that makes that angle 30. Now if that length there is 1, that length there is obviously 1, and this length here is a half. What about this length here? Well, Pythagoras says x squared plus a half squared, which is a quarter, equals 1. So x squared must be 3/4. So x is the square root of 3/4, which is the square root of 3 over 2. Now let's consider this triangle here, just that triangle there, and think about normal trigonometry. From here, the sine of 60 equals the opposite, which is x, divided by the hypotenuse, which is 1. The cosine of 60 equals the adjacent, that's a half, divided by the hypotenuse, which is also 1. The tan of 60 is the opposite, which is x, which is root 3 over 2, divided by a half. So root 3 over 2 divided by a half, there we go, root 3 over 2 divided by a half, that's the same as root 3 over 2 times 2 over 1, which is root 3. Now let's consider 30 degrees. The sine of 30 is opposite, which is a half, divided by the hypotenuse, which is 1. The cosine of 30 is the adjacent, which is root 3 over 2, divided by the hypotenuse, which is 1. And the tan of 30 is opposite, that's 0.5, divided by root 3 over 2. So that's a half divided by root 3 over 2, which is a half times 2 over root 3, which is 1 over root 3. So to summarise that, we get this table of results which show the exact values of the sine, cosine and tangent of 30 and 60 degrees. And very often it's useful to know the exact values rather than the decimal approximations. Now this time let's take an isosceles triangle where that's 45, and that's 90. So if that side there is 1 and that side there is 1, then 1 squared plus 1 squared is 1 over 1, which is 2. So the square root of that is the square root of 2, so this length here is the square root of 2. So the sine of 45 is the opposite divided by the hypotenuse, which is the same as that. The cos of 45 is also the adjacent divided by the hypotenuse, which is also that. And the tangent of 45 is opposite over adjacent, which is 1. If you're not absolutely sure about why cos 1 over root 2 is root 2 over 2, 1 over root 2, let's multiply the top and bottom by root 2 over root 2. So 1 times root 2 is simply root 2, and root 2 times root 2, that's 2. And there we have the special triangles.